Hello friends, we are going to start our 7th lecture of photochemistry, and in this lecture we are going to see Paterno Buchi reaction. Let's see. Okay, in case of Paterno Buchi reaction, it is a cycloaddition reaction of carbonyl compound and alkene. More correctly, I will say it is a cycloaddition reaction of excited carbonyl compound and alkene. Means in Paterno Buchi reaction, the name Paterno Buchi actually it is on the scientist Paterno Buchi, and it is a cycloaddition reaction, means like pericyclic reaction likewise. So it is a cycloaddition reaction of excited carbonyl and alkene gives four membered ether ring called as oxygen. Here we are using cyclic or sorry carbonyl compound and alkene. So finally on addition with photon you will get oxygen, that is a cyclic compound. Okay, so in this case firstly the Paterno-Buchi reaction, as we use photon, as the carbonyl compound absorb photon, the electrons from non-bonding get excited to the pi star. So it is n to pi star transition. In case of nourished type 1 and type 2, we already studied about n to pi star or pi to pi star transition. In this system, that is Paterno-Buchi reaction, here we are going to see about n to pi star transition. Okay, so let's see the mechanism of Paterno-Buchi reaction. See, in Paterno-Buchi reaction, we have to study about carbonyl compound and alkene addition. Carbonyl compound and alkene addition. So, product of this reaction will give you cyclic product containing a ether, means oxygen will be there and four member system will be there. And upon your what will be the alkene you are going to use and carbonyl compound, final product will be differ and addition reaction will be different. Okay, let's see. So firstly, excitation of carbonyl compound will take place. Okay. So as carbonyl compound, here we are using acetone. As carbonyl compound absorb a photon, it will excite it to the singlet state, means higher energy level. Now from singlet state, you can see here double bond from this carbon C double bond O, it will split into two electrons, means two radicals. So oxygen radical here and carbon radical here. Now this system is a singlet state. Okay, so after inter-system crossing, the singlet state will changes to triplet state. Now, what is the main difference between singlet state and triplet state? We have already studied this in lecture first already. So let's see it again, because in Paterno-Buchi reaction, actual bond formation takes place, and the product is depend upon only spin of electrons. So see, when I am saying the carbonyl group is in excited state, means electron is splitted, and in case of a singlet state, you already know this. In case of singlet state, any bond when it is in a ground state or in a singlet state, this spin of two electrons are different, means they are anti-parallel to each other. So it is in a singlet state. When it gives intersystem, it goes to intersystem crossing. The spin of one electron will changes. So both are now parallel. Both spin are parallel. So it is in a triplet state. So firstly it is in a singlet state. Now after intersystem crossing, it is in triplet state. Now this excited carbonyl molecule will undergo reaction with alkene. Now after addition of this excited alkene or excited carbonyl to the alkene, you can see there are two possibilities. If alkene containing electron donating groups on alkene, means substituted alkene will be there, then if alkene contain electron donating group, then product will be different. If there is electron withdrawing group, then product will be different. Let's see first what will be the reaction actually. So see, in case of we have already this excited carbonyl compound and we are going to do reaction with alkene. Now firstly alkene molecule, in alkene molecule here is a double bond, it will again split into radicals. Okay, now see here, after the reaction you can see firstly the carbonyl compound have same spin, means it is in a triplet state, means both electrons are parallel to each other, means in a same spin. But this alkene containing both electron in opposite spin. Okay, So firstly the bond will be takes place in between these two opposite spins. So new bond between this radical and this radical, you will get here new bond. Now the condition here, these two radicals, remaining two radicals are of a same spin, but for the bond formation we require opposite spin radicals. Now see, this newly bond formation will be takes place by two ways, maybe spin changing or by the bond rotation. Okay, let me explain you in Marathi. See, आता आपल्याकडे कंडिशन काय आहे, हा ट्रिपलेट स्टेटमधला मॉलिक्यूल आपल्याकडे कार्बोनिल कंपाऊंड ऑलरेडी आहे, म्हणजे ह्याचे दोन्ही जे रॅडिकलमधले इलेक्ट्रॉन आहेत ते काय आहे, पॅरलल स्पिन म्हणजे सेम स्पिनमध्ये आहेत. नवीन बॉन्ड फॉर्म करायचा असल्यावर आपल्याला काय लागणार, दोन्ही अपोजिट स्पिनचे लागणार, म्हणजे हा वरती आहे पॉझिटिव्ह सपोज आणि हा काय मजला निगेटिव्ह, म्हणजे ह्याच्यावर ते बॉन्ड फॉर्म होऊ शकतो. म्हणजे हा आता कंपाऊंड इथपर्यंत ओके. पण इथे जर नवीन बॉन्ड फॉर्म करायचा झाला या कार्बन आणि या कार्बनमध्ये, तर आपल्याला दोन्ही जे रॅडिकल आहेत त्याचे स्पिन काय पाहिजेत, अपोजिट पाहिजेत. एका बॉन्डसाठी अपोजिट स्पिन रॅडिकल लागतं. बट हिअर कंडिशन इज दॅट बोथ स्पिन आर ऑफ अ सेम, मीन्स पॉझिटिव्ह पॉझिटिव्ह किंवा निगेटिव्ह निगेटिव्ह. ओके, म्हणजे बॉन्ड फॉर्म करण्यासाठी आपल्याला काय करावं लागेल, या कार्बन कार्बन बॉन्डमधला हा जो बॉन्ड आहे तो एकतर काय होईल, रोटेट होईल. तो रोटेट झाल्यानंतर काय होणार, हा जो CH3 आहे तो मागचा CH3 पुढे येणार, मीन्स बॅकवर्ड जो पोझिशन ग्रुप असेल ते पुढे येतात आणि पुढे असतील ते मागे जातात. आणि त्याच्यानंतर काय होणार आहे, म्हणजे कंडिशन काय आहे, when there is electron donating group present on alkene. See, when there is electron donating group present on alkene, it raises the energy of alkene. Are you getting my point? It raises the energy of alkene. Let's see. Okay, in this case this is our molecule. दोन कुठले कंडिशन पॉसिबल आहेत, एक म्हणजे स्पिन रोटेशन होईल, डायरेक्टली स्पिन रोटेशन होईल. म्हणजे ह्या कार्बनचं जे हा जो रॅडिकल आहे त्याचा स्पिन रोटेट झाल्यावर काय होणार, हा जर प्लस हाफ असेल तर तो रोटेट झाल्यावर काय होणार, मायनस हाफ, म्हणजे अँटी पॅरलल होणार या कार्बनच्या रॅडिकल बरोबर आणि बॉन्ड इझिली फॉर्म होईल. बरोबर आहे. बट देर विल बी नो चेंज इन द पोझिशन ऑफ दिस CH3 अँड CH3. ओके, बट इफ बॉन्ड रोटेशन टेक्स प्लेस, बॉन्ड रोटेट झाला, हा बॉन्ड सपोज रोटेट झाला तर फ्रंटला जो CH3 तो काय जाणार, बॅकवर्डला जाणार. आफ्टर बॉन्ड रोटेशन स्पिन रोटेशन विल टेक्स प्लेस. आता ह्याचा स्पिन रोटेट झाला आहे, म्हणजे हा काय झाला, जो अपवर्ड आहे तो काय होणार, डाऊनवर्ड होणार आणि नंतर बॉन्ड फॉर्म झाला आहे. ओके, नाउ सी, टू पॉसिबिलिटीज कुठल्या आहेत, एक म्हणजे डायरेक्टली स्पिन रोटेट होऊन बॉन्ड फॉर्म झाला, दुसरा म्हणजे काय, बॉन्ड रोटेट झाला आणि त्यानंतर प्रोडक्ट फॉर्म झाला. दोन वेगवेगळे प्रोडक्ट फॉर्म होतात. आता ह्याच्यात लक्षात घ्यायची गोष्ट, so when there is electron donating group present on alkene, there will be two possibilities. One will be spin rotation, and directly you will get a same product, means having a same groups on the same side. And bond rotation means first bond rotation will be there. After bond rotation the backward groups come to upward position and upward groups goes to downward position, and then spin rotation takes place. So you will finally get the opposite product or reverse stereochemistry of the compound, and this condition is the major condition and this product is a major product. Okay, so why it is so? See, mainly the energy of alkene is high, then bond rotation takes place and then spin rotation, and finally you will get a product. And when there is electron withdrawing group present on the compound, means alkene, the energy of alkene will be low and only change of a spin takes place and no any bond rotation will be there. Why it is so? When there is electron, see, when there is electron donating group present on a alkene, when there is electron donating group present on alkene, the energy of alkene will be high. It raises the energy of alkene, and in that condition there will be much more time to rotate the bond. Single carbon bond will be rotated easily, and because of that bond rotation is possible and you will get a different product. But when there is electron withdrawing group present on a compound, present on alkene, then energy of alkene goes down, and as the energy down, you can easily consider that if the energy is low, then the compound is more stable, and in stable compound there is no chance to change its bond, means rotate its bond, and as it can't rotate its bond, it just changes spin. So in case of a electron donating compound, electron donating alkene, electron donating groups on alkene, then bond rotation takes place. And when there is electron withdrawing groups on alkene, the energy of alkene is low and there is only change in spin and no bond rotation, means stereospecific reaction will be there. If the in the reactant compound is in a cis form, then in a product it also in a cis form. When it is in a electron withdrawing group, I am saying. And in case of electron donating group, here you can also see as these two CH3 and CH3 are electron with donating groups, finally you will get a trans product as a major product. Means when there is an electron donating group present on a alkene, then the stereochemistry of alkene changes. If it is a cis, then finally it will be in the trans form. And in the reactant, if it is in a trans form, then finally it will be in a cis form. Okay. Now see one more example of this condition. Here, in this alkene you can see we have electron donating groups, this CH3, this CH3 and this CH3. These three are electron donating groups. Now how will you split these electrons? The stability of radical also important in Paterno-Buchi reaction. So because of that only I have taken this example particularly. Let's see. After breaking of this bond, you can see two radicals will be formed. Here will be a one radical and here will be one radical. Out of these two radicals, which will be a more stable? See, जो जास्त स्टेबल असेल तो कमी रिॲक्टिव्ह असणार आहे. Which is a more stable, it will less reactive, and which is less stable, it will be more reactive. More reactive असणार तो लगेच एक रिॲक्शन देणार. याच्यामध्ये जर स्प्लिटिंग झालं तर कोणावरती काय चार्ज येणार? C and O, C रॅडिकल अँड O रॅडिकल. C रॅडिकल जेव्हा येणार, C रॅडिकल असणार आहे, तो काय करणार आहे? तो स्टॅबिलाइज होणार या दोन CH3 ने. हा जो C रॅडिकल असेल तो स्टॅबिलाइज होणार या दोन CH3 ग्रुपने. पण हा जो O रॅडिकल आहे तो काय असणार आहे? कमी स्टेबल असणार आहे. म्हणजे पहिल्यांदा रिॲक्शन देताना कोण देणार? ऑक्सिजन ॲज ऑक्सिजन रॅडिकल फर्स्ट रिॲक्ट. ओके. In this case, here we have on this radical both two groups, CH3 and CH3, and on this radical only one group. म्हणजे जास्त स्टेबल ग्रुप कुठला आहे? ह्या कार्बनवरती दोन इलेक्ट्रॉन डोनेटिंग ग्रुप आहेत, म्हणजे हा स्टेबल आहे. हा जो रॅडिकल आहे तो काय आहे? स्टेबल आहे कम्पेअर टू दिस रॅडिकल. म्हणजे जो लेस स्टेबल आहे तो काय असणार आहे? जास्त रिॲक्टिव्ह असणार आहे. म्हणजे हा काय असणार आहे? जास्त रिॲक्टिव्ह असणार आहे. मग दोन जे जास्त रिॲक्टिव्ह आहेत त्यांची रिॲक्शन पहिल्यांदा होणार आहे. म्हणजे हा ऑक्सिजन आणि हा कार्बन रॅडिकल आणि हा कार्बन रॅडिकल आणि हा यांच्यामध्ये बॉन्ड फॉर्म होणार आहे. लेट्स सी वन बाय वन. फर्स्टली काय होणार आहे? वी हॅव ॲसिटोन. Firstly it goes to singlet state, then after singlet state, after intersystem process, it will goes to triplet state. Now this excited carbonyl will make a bond with this excited carbene, carbene alkene. Okay, so after bond formation, so first bond form will between this carbon and oxygen. Okay, secondly, ॲज इलेक्ट्रॉन, आता आपल्याला काय बघायचं आहे की अल्किनवरती इलेक्ट्रॉन डोनेटिंग ग्रुप आहेत की विथड्रॉइंग ग्रुप आहेत. आपल्याकडे कुठले ग्रुप आहेत? इलेक्ट्रॉन डोनेटिंग ग्रुप आहेत. CH3, CH3, CH3. इलेक्ट्रॉन डोनेटिंग ग्रुप आहेत म्हणजे काय होणार आहे? बॉन्ड रोटेशन होणार आहे आणि बॉन्ड फॉर्म होणार आहे. हे त्या लक्षात, जेव्हा डिफरंट ग्रुप असेल किंवा स्टिरियोकेमिस्ट्री दिलेली असेल तर तुम्ही पर्टिक्युलरली मेन्शन करू शकता कुठले ग्रुप बिलो द प्लेन आहेत, कुठले अबो द प्लेन आहे. इथे तसं काही मेन्शन केलेलं नाही आहे, त्यामुळे डायरेक्टली आन्सर केला तरी चालेल. सो जस्ट पहिल्यांदा काय होणार आहे? रोटेशन होणार आहे, नंतर स्पिन चेंज होणार आहे. म्हणजे हे स्पिन काय होणार? पुढच्या कंडिशनला चेंज होऊन रिव्हर्स होणार आणि फायनली तुमचा प्रोडक्ट मिळणार. ओके. नो नेक्स्ट केस. आत्तापर्यंत बघितली ती इलेक्ट्रॉन डोनेटिंग ग्रुपची होती. इफ देर इज इलेक्ट्रॉन विथड्रॉइंग ग्रुप प्रेझेंट ऑन अ अल्कीन, सो इफ इलेक्ट्रॉन विथड्रॉइंग ग्रुप प्रेझेंट ऑन अल्कीन, इट लोवर्स द एनर्जी ऑफ अल्कीन. एनर्जी काय करणार? अल्किनची लो करणार आहे. त्याच्यामुळे काय होणार आहे? बॉन्ड रोटेशन होणार नाही, जस्ट स्पिन रोटेशन होणार आहे. सो देर विल बी नो बॉन्ड रोटेशन, ओनली स्पिन रोटेशन. सो यू विल गेट फायनली स्टीरियोस्पेसिफिक प्रोडक्ट. ओके, बिकॉज देर इज नो टाइम फॉर द रोटेशन ऑफ बॉन्ड, ओनली स्पिन रोटेशन टेक्स प्लेस, and you will get, if there is a syn compound in reactant, finally you will get a syn oxidant. If there is a trans alkene, you will get a trans oxygen. Acetone is reacted with alkene. Now on alkene there are two electron withdrawing groups, two cyano groups. So as there is electron withdrawing group, there will be a stereospecific product will be there. Means if there is a trans compound, means trans alkene, you will get a trans product, means trans oxygen and the product. And if there is a syn alkene, then you will get a syn oxygen. So in first case there is a syn, both CN on a same side. So after a photochemical reaction, firstly there will be a oxygen radical and here carbon radical will make a bond. Finally, second, we are skipping here bond rotation because this is a stable system and there is no bond rotation will be there, only spin rotation is favorable. And nextly bond form and the same, means position remains same as it is. So we will get syn alkene, then finally product will be also syn. And in next case here we are using trans alkene. Cyano groups are no different, means one is above the plane and another one is below the plane. So finally you will get in a product trans product is there. So in case of electron withdrawing group, you will get same stereochemistry, whatever stereochemistry in alkene reactant, same stereochemistry will be there in the product. So in case of the electron withdrawing group, stereospecific product will be there. And in case of a electron donating group if present on alkene, the stereochemistry will changes. Okay, so thank you for this lecture. In next lecture we will see some more points about Paterno-Buchi reaction, about alkene, means addition reactions of, we have now studied about alkene. In next lecture we will study about alkynes, triple bond, and some more examples.